So we're going to just put positive, negative, or 0 in all these places, but they don't tell you that this is the graph of f of x. That's the only way this is going to work, is if this is the graph of f of x. So again, you got to be careful. Switch your brain. That's not f prime. That's f. So let's do a couple of these together. Let's do all of A and all of B and see what we learn. Maybe C as well. So at point A, is f of x positive, negative, or 0? Negative, because we're below the axis. How about f prime at A? Positive, negative, or 0? Why is it positive? Yes, but what's increasing? I just want to know which one of these is increasing. You said it, and I don't know which one you're referring to. Not f prime. F prime is actually not increasing at A. F is increasing, so you put the right thing, but be careful about the reasoning. How about the second derivative at A?
Positive? No, negative.
Why do you say negative?
Oh wait, no, it's because...
It is negative.
Is it? Oh,
It's concave down.
oh, right.
In fact, maybe we could just relabel these. F prime is the slope of f. F double prime is the concavity of f. Whoops, not the concavity of f prime. That would be... Concavity of f prime would be like f triple prime, so we're not worried about that. All right, at point B, what's f? Positive, negative, or 0? How about f prime? Positive, because the slope is positive, and f double prime? Negative. All right, so okay, we'll do C. Then I'll leave you alone. So what do you think for C? What about f at C? Positive. Like f is just, are we above the axis or are we below the axis? F prime is the slope. What's the slope at point C? 0. That looks like a horizontal tangent line. So that slope is 0. What about the concavity at C? Down, which means what are we putting in this column? You're right, the concavity is down, negative. And by the way, those little x's are points of inflection, so that way you can definitely know if you're concave up or concave down. So finish filling out that table. That shouldn't take too long, and then we'll compare answers and make sure we're okay. So there's the answers. You want to check those. But we have to be careful about what graph are we looking at. We've looked at several f prime graphs, but then we switched back to an f graph. On the back of that page, figure above shows the graph of f prime. Let's see, do we want to do this one? Both of those on the back page are kind of the same. Like they give you a graph, a picture of f prime, and then ask all the same questions about it. Let's do one of them, and then we'll move on to the multiple choice part. I don't know. That second one just looks weird, so let's look at the second one. Just because the graph is stranger than the first one, although it's the same kind of stuff. Let f be a function. Okay, we gotta be careful here. So the graph is f prime. So it says it, I'm labeling it, I don't want to mess up that's f prime. Let f be a function defined on the interval -3 to 4 with f of 0 equals 3. The graph of f prime consists of one line segment, got it, and a semicircle as shown above. Okay. On what intervals, if any, is f increasing? Justify your answer. Well, again, let's justify our answer first, and let's justify in terms of what we know. And what we know is f prime. So what would you say about f prime if f is increasing? It's positive. So I like to justify my answer first, And then I go look and use my justify because that tells me what I'm looking for. So don't just start looking at the graph and guessing. Justify first, and then that tells you what to look for. So f prime is positive from -3 to -2. And that's it. It's negative after there. And again, when AP says justify your answer, that's what it's looking for. It doesn't mean, write me a paragraph explaining the history of derivatives. It means, how do you know that f is increasing? Well, you know when f prime is positive. So say what you need to say, but say it briefly. You don't need to spell it all out. Part B, find the x-coordinate of each point of inflection on the graph of f. Justify your answer. Well, again, we're going to justify our answer with what we're given. We're given f prime, or at least we need to get to something about f prime. What do you know about point of inflection? We're using our way through this here. How do you find a point of inflection in general? So not on this picture, just in general, what's a point of inflection? So when f double prime changes signs. Not when f double prime changes concavity, because that would be like a fourth derivative, right? The concavity of f double prime would be f quadruple prime. But when f double prime changes signs, that does mean f changes concavity. Then we have a point of inflection. That's true. That's not really helpful for this graph because this graph is f prime. So what could I say about f prime that would tell me the point of inflection? What would I be looking for? What could I say about f prime? What's that? Good. Yeah, we could say, that's a good way to say it, the slope of f prime. Slope is a derivative word, so slope of f prime is just another way of saying f prime prime, or the second derivative. So the slope of f prime changes. So where does that happen? What x values does the slope of f prime change? Changes signs. I guess we should be more specific. So where does it change signs? Well, it's so decreasing, 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 increasing. So x equals 0. It changes from f prime changes from decreasing to increasing. Where else? There's one more place where it changes, where f prime changes its slope. X equals 2. That's where f prime changes from positive to negative. So that would make a relative max. F prime changes from positive to negative. We're looking for where the slope of f prime changes signs. So where f prime changes from increasing to decreasing or decreasing to increasing. Right there, f prime is decreasing, decreasing. So it's concave down all the way through. F is concave down all the way through there. Because f prime is decreasing. But right here, f prime changes from decreasing to increasing. So f double prime changes signs. That means it's a point of inflection. The slope of f prime changes. Part C, find the equation of a tangent line. So I need slope and point. to the graph at the point 0, 3. Well, it gave me point 0, 3. What's the slope of f at 0, 3? At x equals 0. What's that? Well, look at my... What is this graph a picture of? F prime. What's the slope of f? That means f prime. I want f prime at 0, which is negative 2. So I didn't have to take a derivative. I had to read off a derivative. The derivative at 0 is negative 2. So the slope of f at 0 is negative 2. Now it's easy because I know the slope. It gave me the point. Y minus 3 equals negative 2 times x minus 0. That's probably an old AP test question right there, where they give you f prime and then ask a bunch of questions about it. Let's see, multiple choice. Let's do the first one. And then we'll see what else we need to worry about. The graph of the derivative of f is shown above. Again, they're not trying to trick you on what graph they're giving you. They're giving you the graph of the derivative. Which of the following could be the graph of f? Oh, this is tricky because we haven't done this much. Not yet, anyway. So let's pick out some key points and figure out what's going on. So at x equals negative 1, what's happening to f prime? Yes, and if f prime changes positive to negative, it's a relative something. So just draw the picture in the air. Like if f prime changes from being positive to negative, that means f has a relative max. Okay, so there's a relative max at x equals negative 1. So it almost has to be B. E is a maybe, but it's definitely not A. Relative max at x equals 1. So that looks good. C is definitely out. A is out. D is out. A little curious about E because is that a max? It's kinda. Let's see, what else could we learn? What's happening right here at x equals 0? What's happening to f prime at 0?
Isn't there a change in the derivative? Like it's a curved line and can't be going in a straight line?
So we have to be...
Because the derivative would be the same whole line, right?
So you can think of it that way. If this is f of x, that means f of x is whatever. It's a negative whatever. If it's negative 2x, then what would the derivative of that be? Negative 2. Well, whatever this slope is, the derivative is whatever the slope is. And that means the graph would be some constant at negative 2. So yeah, you could use that to figure out that that's not it. One more thing though about x equals 0, because we struggled with this a minute ago. What's happening to f? Well, let's first say what's happening to f prime at x equals 0. Well, it doesn't change. F prime doesn't change from negative to positive. F prime is all negative down there. There we go. The slope of f prime changes. And slope of f prime, that's f double prime, And if f double prime changes, yeah, that's a change in concavity. That's a point of inflection. So at 0, there should be a point of inflection, and that fits for B as well. That looks like a point of inflection. All right, I think number 2 is pretty straightforward. Three is sort of backwards from what we just did. The graph of f is shown in the figure above, which could be the derivative of f. So all our answer choices are f prime. So it's kind of backwards, but we would still use increasing, decreasing slopes, all that kind of stuff to figure out which one of these it is. Let's look at number 5. Good old absolute value. We don't like taking its square root, but we know something strange is going on at the places where the cusp is. Number 5, let f be a function defined for all real numbers. F prime. Okay, so they're giving us the derivative, so I don't have to take a derivative. It's like, here's the derivative. F is decreasing on the interval. So decreasing on interval sounds like I need a number line for f prime. What numbers go on the number line for f prime? Like, how do I know where to put the markers on there? Think back to the little flow chart here. Critical points lead to possible extrema, and then you can go table of values. You can go first derivative test. That's the number line. That's the path we're on. Or you can do second derivative test. But for us, this problem is first derivative test. So they've sort of jumped in back here at the end of this saying number line, but let's back up. How do I find critical points? Right, it's where the first derivative is 0 or undefined. So that would be at 2. That would make the bottom 0. What would make the top 0? Anything else make the top 0? -2. I square -2, I get 4. So 2 makes the top and bottom 0. That sounds fishy or something weird maybe going on. So -2 and 2. So my test points could be -3, 0, and 3. And where am I testing those? That's an easy one for this one. F prime, or f double prime? If I want to know where things are decreasing, I should check them into f prime, which is what I have, thank goodness. I have no idea what f would be that would give me this as an f prime. I have no idea what f double prime would be, but they rigged this problem where I don't need to worry about it. So if I plug in -3, oh, well, the top's always going to be positive. The bottom would be negative. So f prime would be negative. If I plug in 0, again, the top's positive, the bottom's negative, so f prime is negative. And if I plug in 3, I get positive in the top over positive in the bottom. So positive. Let's make sure we answer the question right here. So f is decreasing when f prime is negative. So that would be from negative infinity up to 2. Which should be A. By the way, all of these are old AP test questions. So. All right, so give those a try. If you want do you want the review? Officially, it's tomorrow's assignment. Do you want it right now?
Yeah.
Thought so.
Just the middle.
It's short. So now you have all of the worksheets for the unit. Tomorrow we'll just do more questions that you have and go over stuff.
Mr. Wolf.
Yes.
One thing I'm pretty sure.